Hello guys, in this video we will be talking about solid principles. What are the 5 solid principles? The 5 solid principles are single responsibility principle, open closed principle, risk of substitution principle, interface segregation principle. Let's start with the first one, the single responsibility principle. Single responsibility principle is all about having only one reason to change. Well, you are talking about a class, whether you are talking about a package, a component or an application, this should all have responsibility. You should be able to define what an application is doing in a single line, and when you are able achieve your single responsibility principle, you would see that the amount of possibility of reuse would increase. Look at this specific class. It's responsible for downloading something from the internet. It's responsible for pausing something. It's responsible for saving the data to the database. Is that meeting the single decimals will be principle? You will be able to reverse this kind of code anywhere else? The answer is no. Let's look at another example. This is actually doing a calculation of a page, creating a report, and it's saving the employee details to the database. These are classes with multiple responsibilities. So, single responsibility principle is all about having classes which do one thing. The second most important principle is the open closed principle. It says software entities should be open for extension but closed for modification. What does that mean? Look at this implementation of calculating area for a shape, just pausing in an array of shapes, and we are checking if a shape is rectangle, then do this, else do this. What if I have to add a few more shapes? All the logic would be centralized in this specific piece of code. So whenever I add a new object, then I should start modifying all the code which is present in the area method. Now what would be a better solution? The better solution would be allowing each of the shapes to define their own area method. So here we are creating an abstract class called shape. This could also be an interface, and we are creating a area method inside the rectangle class. Implementing the abstract method in here, the area method only be responsible for looping around them and calling the area method on their specific shape. So this area method is now having only the logic to loop around the shapes and add the areas. In this is a very good example of open closed principle. Enough if you want to add a new shape, you don't really need to change the area method. So this area method is closed for modification. You don't need to change this, but we are open for extension because whenever you would want to create a new shape, all that you need to do is to create the shape and define the area method inside it. So we are open for extension, open for new shapes, but we are closed for modification. We don't really need to change the method. The third principle is the list curve substitution principle. One of the things people tend to do in object-oriented programming is try and use inheritance even when it's not really the right thing to do just for the sake of reversing the code. List curve substitution principle says subtypes must be substitutable for their base types. Let's consider an example. Let's say there is a rectangle class and we have a set width and the height method which is implemented, and we have get height and the get width method as well, and not there is a new requirement to implement a square class. And what I do is, instead of trying to implement a square class on its own, I would try and extend the rectangle class. Well, I would say square extends rectangle, and I create a set width method where I would set both height and width to W, and I would do the set height method where it says both height and width to H is that a good implementation? Little substitution principle says it's a bad implementation. Consider a piece of code like this, right? So if somebody wants to test a rectangle, let's say this is the method which is written here, dot set width 5, set height 5, and he is checking if the area is 5 into 4. Will the square class pass this test? The answer is no, because your set height is actually setting both height and width to the same value as height. So what would happen is set height 4 will be set both height and width to 4. So the area would be 4 into 4 and it will not be 5 into 4. You should always be careful when you use inheritance. You should use inheritance only when your superclass is replaceable by a subclass. In all the instances, don't use inheritance just to save a few lines of code. The fourth principle we will be talking about is called the interface segregation principle. When two systems or two classes are talking to each other, then they should have the smallest possible interface that is defined. Why it is important? Let's take an example. Let's say I have an animal interface which is having an abstract feed method. We are creating two classes, dog and tiger. Implement the feed method. Let's say now I would need to add a feature to groom. What would happen if I add the groom method to the animal interface? What would happen is the dog and the tiger need to implement the groom method. Groom is something which would only be applicable to domestic animal. So I can groom a dog, but for a tiger I am providing a dummy implementation just to keep the compiler happy. He said good implementation. The answer is no. The ideal way to handle that would have been to create another interface called a pet. Instead of adding features to the existing interface, it's better to create a new called pet. Extending the existing interface and adding the groom method in the dog can extend the pet interface because groom is applicable to it, but tiger would continue to extend the animal interface. That's what interface segregation principle is all about. Keep your interface as small as possible. The moment you have fat interfaces with a lot of methods, then every time you change the interface, then it means that all the implement classes also should change. The fifth principle that we will be talking about is dependency inversion principle. It says depend upon interfaces or abstraction rather than concrete classes. What does that mean? Let's look at an example. Look at this implementation of the coffee method. What it's doing is based on the output device which is passed in, which would be printer or a disk, whatever is from the keyboard. It would be written down to the output device. So you can see the logic for it in here, right? So you read it from the keyboard and you checking if the output device is printer, then write printer, else write disk. Now what is the problem with this? Is the problem is as your number, if output devices increases, this copy method needs to keep changing. A better implementation would be to create a simple interface like a reader and have an interface writer, and the copy method can write from any reader to any writer, so the copy method does not change. When you have a new writer or a new reader, this is a good example of a dependency inversion principle. In this video, we looked at solid principles. The idea was just to quickly introduce you to all the principles with a few code. Example, we will look at single responsibility principle, we looked at open closed, we looked at Liskov substitution principle, and we looked at the interface segregation principle as well as the dependency inversion principle.